Hi students, welcome to THATSIIT YouTube channel. I am KASU sir discussing the JEE Advanced 2023 related topics through the numericals which were asked previously in JEE. As we have completed the 3 sessions where comprehensively we had covered the stoichiometry part, then states of matter along with atomic structure, chemical bonding and the periodic properties. Also, in the first term of this session, we had covered certain question related to the thermodynamics and equilibrium. You know that when you are writing the JEE advanced examination, the complex topics or chapters are to be emphasized more so that you can score on par with the toppers. That means if you are aiming any score between 150 and above to 220, then your emphasis must be on the important as well as the logical chapters. And in that category, the thermodynamics and equilibrium falls. So one has to understand that there is a fusion of the concepts in the thermodynamics as well as the equilibrium, which is making the whole unit appear stronger at the same time complex. Now it gives a feeling that the questions are difficult to understand, but once if you get into the information, that means the details of the question, you will start slowly feeling that yes, I can solve the question. So what you must have to solve these questions is the perseverance and endurance and data interpretation. Especially in thermodynamics, when the questions are asked, don't be in a haste to attempt it, rather look at the question, analyze the data, write it up front and then only try to solve the question. It's not that you're going to solve the question within 2 minutes like you do in the other entrances. But in JEE Advanced, the question require time to understand, not to solve. So once if you understand, you can easily solve. And understanding becomes more and more difficult when it comes to the chapters like the thermodynamics and equilibrium. So that requires not only patience but acute attention. So while solving the question related to this, I want you to completely focus on the question, the data interpretation I mean. After the interpretation of the data, you can easily solve the question. So with this note, let's start the question of the day, which is asked from the equilibrium. You can check. It is somewhat related to the ionic equilibrium, isn't it? Now you can see some questions involve the calculations but not logic, and this is one of such questions. You can see that the solubility of a salt of weak acid AB at pH equal to 3 is somewhat like y into 10 power minus 3. You need to find the value of y. However, there is another information which is provided related to the KSP of the salt and also the ionization constant of the HB, because you know that the weaker acid is HB whose Ka value is given. Now based on the information which is given in all such questions, you need to first write the equation pertaining to these values. Now you know that it's a insoluble salt, so it dissociates partially. So you first write the equations pertaining to the values that they give. Always remember this trick. You need to write the equation and minimize the number of equations or the variables. You can see that over here the B minus is actually the conjugate base of a weak acid, hence it is stronger. It is going to combine with the H plus ion that are present in the solution, maybe from water or from the BH. Alright, and you know that the equilibrium constant for this is 1 by Ka, because opposite of this is actually the dissociation of HB. And whenever you are opposing the equation, whenever you are writing the reverse of the equation, your equilibrium constant is actually inverted. That's what we did here, isn't it? Now let's assume that the solubility of this salt in terms of S, I will write rather, the solubility of the salt, right? So I have assumed that the solubility of AB is equal to somewhat X mole S mole per liter. Alright. Now you can see this B minus is S moles. Now it's mentioned that at pH equal to 3, that means the resultant concentration of the H plus is actually 10 power minus 3, because you are given that pH equal to 3, that pH equal to negative log of concentration of H plus, hence the concentration of H plus is 10 to the power, that is anti-log if you take minus 3, that I am writing here because you have to find the solubility at that pH. This is the equilibrium value which is given, hence some x moles of, let's assume that B minus is reacting in this process and B minus is common over here, and some x moles of Hb is produced, because for 1 mole of Hb is produced. Now we have got two equations, isn't it? One is S into S minus x is equal to Ksp. So you have to write the equation, then only interpret the data. And what else you have? The equilibrium constant is how much? 1 by Ka is equal to x upon 10 to the power minus 3 into S minus x. Now the question is almost done. We have entered into the calculation part from the concept part. I mean, now you can easily solve these questions, right? Now let's substitute the values and check. You can see that Ka value is given 10 power minus 8. So this is 1 by 10 power minus 8, that is 10 power 8 is equal to x by S minus x into 10 to the power minus 3. Alright, you got it, isn't it? This implies x by S minus x is equal to 10 to the power 5. Now we got two equations on the whole here. This is equation number 1 and this is equation number 2. Alright, you got the equation. Now we have got to solve these equations to get the answer. How are you going to do that? You can see this equation 1 has S minus x and also 2. So what I am going to do is I am going to multiply 1 and 2. When I am multiplying 1 and 2, you can see what do I get? S into S minus x multiplied by x by S minus x. So your S minus x got cancelled. So I am going to get S into x is equal to Ksp into 10 to the power 5. You can see that Ksp value is 2 into 10 power minus 10. So 2 into 10 power minus 10 into 10 to the power 5. The value is turning out to be how much? 2 into 10 to the power minus 5. You got the value of xs. You need to find the solubility, isn't it? So I will take equation 1 again. Alright, you can see s square, right, minus sx is equal to Ksp. You know the value of Ksp, isn't it? 2 into 10 to the power minus 10. Alright, 2 into 10 to the power minus 10. Now you can see s square minus, you got the value of sx, 2 into 10 power minus 5 is equal to 2 into 10 power minus 10. Now when I am comparing these values, you can see this value is much greater than this value. Therefore I can write that s square equal to 2 into 10 power minus 5. So the value of s finally is equal to under root of 2 into 10 to the power minus 5. That's it. Now you can see this value is given as y into 10 power minus 3. Alright, so you can solve this question upfront now. Alright, you can just simply write this as root 20. Something like 4.5 into 10 to the power, alright, 10 power minus 3, y into 10 power minus 3. So y equal to approximate values I am writing. I am not writing the correct value here. I am not doing any calculation part here. So this is how we are going to find the solubility of the salt after comparing with the solubility which is given over there in terms of y. I hope you understood. Alright, let's move on to the next question. You can see there is a question related to the equilibrium, connecting that to the second law of thermodynamics. Now there are two equations, as you know, that reactant and product are interconverting into each other, that's reversibility, and at the stage of equilibrium the concentration of these two remains constant. That's what is happening with the time. The concentration of A got decreased and it's remaining stationary at a particular temperature. Alright, where you can see that temperature T2 greater than T1. So there is more product of the reactant that is consumed at the temperature T2 as time passes by. Similarly, the same thing is happening with the product, but the reverse will happen, right? So as the temperature is increased, the product concentration is more influenced, that is decreased. Alright, now the information is, graphs are only to confuse you. The excessive information which is given JEE Advanced might not be always useful. That's why it's called excessive information. So don't get fumbled or panicked by the excessive information, graphs or the critical language what the JEE Advanced will adopt. Their intent is to see how strongly you can combat with the concept of the question. It's not that if the question is difficult to understand, you will just give up. That is not the agenda. One must understand that irrespective of the language, irrespective of the way of asking the question, irrespective of the excessive information, you should be strong enough to combat these questions. So that is the motto of learning, isn't it? That's how you should learn. So the JEE Advanced aspirant doesn't give up that easily. He or she understands the clear-cut difference between the useful information and the excess information. So this graph won't help you in solving the question which is related to the second law of thermodynamics and equilibrium. This is only to tell you the fact that when the temperatures are being altered, the concentration of A and the product would get affected accordingly. Now this won't give you at the same time the complete answer about it. Only what can give is that the natural logarithm of K is the what you call, they are talking about the ratio of the L and K, right? You can see that K1 is the equilibrium constant at T1 and K2 is the equilibrium constant at T2. Now they are talking about the ratio of these values, isn't it? Now you can see it is given that natural logarithm of K1 by natural logarithm of K2. It's not natural logarithm of K1 by K2. You can see the ratio of ln at T1 and ln at T2 is greater than T2 by T1. These values are greater than T2 by T1. This is sufficient for us to crack the question. That is why don't look at that graphs and try to interpret something which is not relevant to the question which is asked. That's what we do, right? So what will happen here, when you are writing it, you will get T1 natural logarithm of K1 greater than T2 natural logarithm of K2. Now you see what I will do on both the sides, I will keep R, okay, then this will become what, delta G1 naught minus, because you know that in equilibrium we have studied that delta G naught equal to minus RT natural logarithm of K. This talks about the spontaneity based on the equilibrium constant, isn't it? Spontaneity is checked through the equilibrium constant. If K value is greater than 1, then delta G is negative, that means the equation or the reaction is spontaneous, otherwise not. You can see minus delta G1 greater than minus delta G2 naught. Alright, so we are talking about two conditions, T1 and T2, and we are talking about the changes, right? The statement related to the changes in enthalpy, entropy and Gibbs free energy. Now this is the value at T1 and this is the value at T2, and you know that delta G naught on the net equal to delta G naught at higher temperature, alright, isn't it? You can see these values, right? Delta at higher temperature minus at lower temperature. Now one can make out that the delta G1 naught value is greater, isn't it? Minus is only to show that it is decreasing. Minus had got not the numerical significance here. Please understand this. You can see that delta G1 naught, this value is greater. That means the delta G net is less than 0. That means delta G naught is less than 0. You can see it is matching in these three options. It's almost there in all the options, isn't it? Now we are going to substitute another expression, that is delta. We also know that delta G naught equal to delta H naught minus T delta S naught, isn't it? We check the spontaneity of a equation based on the delta H and delta S, and this is that equation, isn't it? Now we know that equation, so I am going to take this equation into consideration so that I can answer the next parameter, isn't it? Now I am going to substitute it over here. So I will get minus delta H naught plus T delta S naught. Alright, over here I must say that this is T1, alright, this is H1 and this is S1 greater than minus delta H2 naught plus T2 delta S2 naught. Over here you can see clearly that T2 value is greater than T1. It's given that T2 is greater than T1. Therefore, we can make out the conclusion that here again delta H1 naught is greater than delta H2 naught. That implies the delta H of the net equation, which is equal to delta H2 minus delta H1, is also turning out to be negative. So we got these two negatives. So where else it is there? Yes, you can see over here that delta H naught, no, that is positive, right? We need to get the negative value, isn't it? Where is negative? Yes, over here. Delta H naught is negative, and so these two we have matched. So this is left out, right? Delta H naught is left out. You have to sort out the data. Over here you can see clearly that delta S1 naught, simply once again delta S1 naught greater than delta S2 naught from this expression only. Therefore, delta S net is also negative. Alright, so these two are the right options for the given question. So pure mathematical question. Alright. Next question is actually from equilibrium. Let's see. This is again related to the interpretation of the data. Now we can see that equilibrium constant is mentioned. Alright, so Fe plus 2 plus S minus 2 is in equilibrium with FES, which is a solid. This is opposite to the solubility of FES, isn't it? Now we can see equivolumes. Now let's assume let volume of a solution equal to some V liter. When they are mixed, you see the resultant concentration. If you want to find out the resultant concentration, you have to find out the resultant moles. So 0.06 into V, that is molarity into volume, will give you moles, right? Similarly, this is 0.2 into V. So I got the number of moles. Now when I am dividing this with the total volume, which is equal to V plus V, you know that I am getting the concentration of these two as 0.03 and this value as 0.1. Now we can see these two have arrived at the equilibrium wherein the concentration of Fe plus 2 finally is given as some y into 10 power minus 17, because what is happening here, that when you have mixed them, the equilibrium had gone in the forward direction, and you can see the equilibrium constant for this is 1.6 into 10 power 17. That means this value is what? Very high. That indicates that almost the entire amount of this Fe plus 2 maximum consumed, isn't it? That means almost the same amount is consumed, some amount is left out, this much is left out, so how much is remaining? 0.07 molar is the concentration of this which is remaining, right? Now you can see equilibrium constant, you are going to substitute 1.6 into 10 power 17 is equal to concentration of the solid 1 by concentration of Fe plus 2 y into 10 power minus 17 into concentration of S minus 2 is turning out to be 0.07. Therefore, y into 10 power minus 17, you will get this value, isn't it? 0.07 divided by 1.6 into 10 to the power minus 17. So your 10 power minus 17 gets cancelled and you will get your y value. Now, I am not doing the calculation part, you can do it better than me. My duty here is only to explain how simply we can solve the questions. The agenda is very simple. Learn the concept such that you can get the idea to solve the question. It's not that you are learning so that you can definitely get the answer. The point is, answer is not in our hands, only the idea. When you solve the question, after getting the idea, there are chances of getting the right answer. These are not JEE main question where the questions are straight, where every question can be solved very easily. One should get the idea, one should grasp what is asked, what is given, etc. Some questions can be at the same time simply what you call the formula oriented, like you could see that the activation energy, you know that activation energy based only we write the KF equation is activation energy is EF upon RT, and for backward is KB, AB e power minus EF by RT. These are the two equations that we know. See, we have to link up it with the delta G. That means what I have to do is I have to take the ratio of the forward and backward rate constant, which is nothing but equilibrium constant. What do I get? AF by AB into e power EB minus EF, isn't it? When I am dividing it, I will get EB minus EF upon RT. Are you following? What do you say? So you can see that the equilibrium constant for this, which is equal to K AF upon AB, and you can see over here that the pre-exponential factor, that is nothing but Arrhenius factor, for the forward reaction, that is AF, is 4 times of AB. So 4 times of AB upon AB into e power. You can see that when this reaction is taking place, that the activation energy of the backward reaction exceeds, that is EB minus EF. EB is greater, exceeds means, isn't it, by 2RT. So EB minus EF is also given 2RT by RT. Now you can see whatever get cancelled, you please cancel it out. So you got K equal to 4 into e power 2. So you will be getting natural logarithm of K equal to natural logarithm of 4 plus 2. Isn't it? Now what is that you need to find out? You have to find out the delta G naught. You know that delta G naught equal to minus RT natural logarithm of K. Substitute minus 8 RT value is directly given here. Need not look at it R value. You can see that RT value is 2500. Natural logarithm of K is nothing but natural logarithm, that is 2.303 into log 4, that is 0.6 plus 2. This is the value of delta G naught. Hope you understood. This is somewhat easier in the session, I felt, because this question is related to the formula substitution mostly and data substitution, right? You know, this question looks to be a little bit interesting and takes the toll out of you, because once if you understand, you can solve. But understanding the concept, the trickier concepts related to the JEE Advanced is a very important here. By the discussion of this question, I am trying to convey you the concepts related to it at the extreme levels. Now we can see what's given here, that you have got NaOH and acetic acid. Every time you are taking certain amount of these two substances, but you are diluting it to 60 ml or to 80 ml or whatever. So you can see net volume initially was 30, was diluted to 60. Over here it is 20 and 20 was diluted to. That means every time we are doubling it always, and we are checking how does it affect the concentration of H+, that is the pH. So this is somewhat related to what you call the buffer or the salt hydrolysis concept. Further, we need to see whether we are dealing with these solutions at the end point of the titration or before the end point. One has to understand that before the end point of the titration, we use a concept called as buffer, because the acid will still remain. Whereas at the end point, remember that we are going to use salt hydrolysis, because your entire weak acid is converted into the salt. So the only component left out is the salt. You don't have any weak acid, hence you cannot apply buffer concept. So based on this simple hint, let's try to solve this question, but this page won't be sufficient. I'll move on to the next page, isn't it? But we need to know that for option P, what is given. Okay, you can see for option P, we have got 10 ml of NaOH and 10 ml of acetic acid was diluted to 20 ml of acetic acid and diluted to 60, isn't it, right? Alright, let's see. What did we take there? Option P, we took CH3 COOH plus NaOH. When you are mixing, convert that into moles. You cannot solve it by taking concentration directly. You have to see what are the millimoles of the solution which were given initially, isn't it? I'll go back. You can see 10 ml and 20 ml. 10 ml of 20 ml of acetic acid and 10 ml of NaOH. That means before the end point of the titration, isn't it? So this is millimoles. I am writing molarity into volume, and this is given as 0.1 into 10. Now we know this only will be completely consumed, limiting reagent concept. 1 mole reacts with 1 mole, so 10 has gone, 20 may say. So how many are remaining? 0.1 into how many are remaining? 10. And how much of sodium acetate is produced? We are not concerned about the pure liquid. 0.1 into 10. Isn't it? No matter whatever is the volume of the solution, whether this volume is 10 plus 20 or this is diluted to 80, it doesn't make any difference, because this combination of weak acid and its salt will make a buffer, and the buffer equation is pH equal to pKa plus log concentration of the salt, that is 0.1 into 10 by V upon 0.1 into 10 by V. So for any value of this V, the pH is going to remain constant, isn't it? Got the idea? Have you understood? So take the screenshot wherever you require the information, please take the screenshot. Hope you understood, right? So what's matching with what? Let's find out. You can see for this P, the value of H plus does not change upon dilution. So we understood that the P is matching with 1, so these two are ruled out. So next case is 20 ml of NaOH and 20 ml of H2. That means we have reached at the end point. Now the interesting picture comes, right? Let's see. The second one. What that you are taking here? You have got acetic acid and NaOH. This is 0.1 into 20 and this is also 0.1 into 20. Now we know that they completely get neutralized by each other, so the concentration of these two remaining is 0. However, this will be 0.1 into 20 upon 20 plus 20, that is 40 if you take the initial concentration of this one before dilution. C1 is before dilution, isn't it? I hope you understood this concept. Before dilution, alright. Now after dilution, what is happening is, like, 0.1 into 20 was diluted to 80 ml. So this is the concentration after dilution. Therefore definitely there is an impact in the concentration of H plus as well. So what's happening here is that the sodium acetate in the case 1, I'll take this case 1 and this as case 2. Now your acetate ions are undergoing the hydrolysis, isn't it? You know hydrolysis concept. Acetate ion is a stronger base because acetic acid is a weak acid. So it will fight for H plus ion from water. We got this. And concentration of, initially I am writing these values. 0.1 into 20 by 40, alright, 0.1 into 20 by 40, that is 0.1 by 2, that is 0.05 into degree of hydrolysis, I'll assume as H, and KH equal to KW by, KH equal to what? KW by K, I am writing this as it is, equal to 0.05 into H square upon 1 minus H. I will neglect H1 compared to 1, so this value I will get, and concentration of OH minus initially is nothing but I will take the H plus also into consideration, equal to how much? How much is concentration of OH minus? 0.05 into H. Alright, so you got H value here. So you will get concentration of OH minus. I will substitute first the H value over here. Let me take the H value first. You got the value of H, that is KW by K into 0.05 square root of, I will call this as H1. Therefore concentration of OH minus, which is in the first case, is CH, that is 0.05 into H. H value is under root of KW by K into 0.05. So concentration of OH minus in the first case, we got under root of KW into 0.05 upon K. So you got here the concentration of the OH minus in terms of C1. Now I'm going to substitute that for the OH minus in the second case after dilution, isn't it? So under root of Kw into, you can see this value, all right, 0.1 divided into 1 by 4. So this value is 0.1 by 4 by K, isn't it? Now you got these two values, and you can even find out the concentration of H plus, because you know that concentration of H plus is equal to Kw by concentration of OH minus, or you can straight away compare here that concentration of H plus is 1 by, you can see, you can mark the difference here, this is 0.05 and this is 0.025, that is under root. The difference is 1 by root 2 times, isn't it? So you can go back and check the option that it is root 2 times, right? Root 2 times its initial value. So this fifth option is matching. When you simplify that, you will get that root 2 times of initial value. So we got P11 and Q as 5. Alright, so this option D is matching. So I want you to take the screenshot of this. Alright, take the screenshot of this, so you can see that the concentration of H plus is how much? The value of H plus changes to root 2 times of initial value upon dilution. That means what? Concentration of H plus in the final stage, when you simplify this, you will get is root 2 times of the concentration of H plus in the first case. That is the comparison between the two. So that I want you to compare, right? You know, this is how we proceed actually. Alright, take the screenshot and save it. Alright, now you can see that you can solve this thing also in the similar manner. The same manner, you will get probably 1 by root 2 times. This is somewhat similar, because you see 20, 20, 80 is the difference, right? So you can solve it. Now nickel hydroxide, excess of nickel hydroxide is diluted 20 ml, right? You can see it is mentioned as saturated solution, right? So nickel hydroxide is mentioned as saturated solution, and saturated means already it is at equilibrium, right? Already it is at equilibrium, so it is just saturated, isn't it? So when it is saturated, the concentration of OH minus should remain constant. So this also does not change upon dilution, because it is a saturated solution. So option S seems to be a little easier as compared to P, Q and R. So right answer is D. Alright, hope you understood. Now let's see this question. Alright, you can see that there is a reversible cyclic process of an ideal gas which is given, right? Where the thermodynamic parameters are compared for various processes ranging from A to B, B to C and then C to A. This is a cyclic process. And over here you need to identify what process is it. You can see that from A to B, I will write over here space constraint. AB is, you can see the temperature is remaining constant, isn't it? So AB is what? This is very important, right? First of all, identify what process is that. AB is isothermal. Temperature is remaining constant. So I will consider it moving from A to B, isn't it? Because for majority of the question you have AB. So AB is isothermal. And look at this B to C. What is remaining constant? You just check. You can see that P2, and over here is also P2. Rest of the two parameters are changing, isn't it? So BC, pressure is remaining constant, that is isobaric. Very important, right? First of all, you should know, right? Isobaric. And over here the temperature has changed, but volume is remaining constant, V1, and here also V1. So the Ca, alright, the process Ca is isocoric. This is very important in understanding whether that is isobaric, isocoric, etc. Once if you understand this, you can easily solve the question, isn't it? Now let's look at the options very carefully. It's a cyclic process, right? and I will take as a precautionary measure, I will write certain information related to this upfront here. So for cyclic process, I will take this excessive information which is useful and helpful. You can see for cyclic process, state function, because it is ending again at A, I will write delta U of the total process is equal to delta U of AB plus delta U of BC and delta U of CA is equal to 0. The total change is 0. Similarly, I will write delta H equal to delta H AB plus delta H BC and delta H CA equal to 0. So we just made them 0 because it's a cyclic process, because that will be useful somewhat, right? Now you can see that your option A has the information related to AC, BC and AB, right? Isn't it? Now you see, first let's pick it up how this goes. Let's talk about the work done in AB. Option A I am checking. You know that AB is isothermal, isn't it? AB is isothermal process. Please look at it carefully. And in AB, the pressure has changed from P1 to P2 and volume also has changed from V1 to V2. You can see that pressure has changed from P1 to P2 and volume also has changed from V1 to V2. So this equation seems to be incorrect. We will check this later, because you can see that it is there in the other equation also. Somewhat close relationships are there in the other equation also. QAC equal to delta U BC. You can see this is there in A as well as option C. So we will check that later, but right now we can see that for isothermal process, if you have to find out the work done, it should be actually delta of PV, because both values are changing, isn't it? So this is not matching, isn't it? What do you say? So the second information is not matching. Hope you are following, isn't it? The second information is not matching. Therefore, in option A, this is not matching. Hence, I will rule out option A completely. Okay. So let me move on to the option B, WBC, that is work done in this BC process. BC is nothing but isobaric. Isobaric means what? Constant pressure, right? For this option B, you can see pressure is remaining constant, that is remaining at P2, and volume W equal to minus PdV, minus pressure is remaining constant P2, dV, that is final V1 minus V2, or you can write this as P2 into V2 minus V1. So you can see this is correct, isn't it? So for option B, the first sentence is correct, first statement is correct. Let's check the second statement related to this, whether this QBC will be equal to delta H of AC or not. For that, I will take these two equations into account. Alright, you can see that I will call this as equation 1 and equation 2. Please watch carefully. From equation 1, you can see that delta U of AB, because it is an isothermal process, that delta U pertaining to this process equal to 0, because you know that isothermal process delta U equal to 0. Therefore, what do you get here? 0 plus delta U of BC is plus delta U of CA equal to 0. Right? We are talking about which process? BC, isn't it? Isobaric, where pressure is constant. Okay, we'll do that. You can see that delta U of BC equal to minus of delta U of CA. So I'll keep it aside, right? Now I got this expression which I will be using accordingly as per my needs. Alright. And we can write the same expression from to delta H of BC equal to minus of delta H of CA, or delta H of BC, because you can see that reverse of this, that is when I am taking AC, that is opposite of that, the sign will change. Alright. And you know that BC is isobaric, and at constant pressure you can write the heat is nothing but enthalpy change, that is Q of BC is nothing but delta H of BC. So delta H of BC can be written as what? Q of BC. So you can see this is also matching. So Q of BC is equal to delta H of AC. So option B seems to be correct. Alright. Option A ruled out, option B is correct, and Q of AC is delta U of BC. This is, let's see, option C. Q of AC is delta U of BC. So what I will do here is that delta U of BC, isn't it? So we are closing down, right? AC, we are talking about what? AC. You know that I am checking option C. AC or CA is actually what? Isochoric. For isochoric, you all know that Q of AC is nothing but delta U. Heat at constant volume is nothing but internal energy change. Alright. So I am going to substitute over here. So I got delta U of BC, isn't it, is equal to delta U of AC, which is nothing but Q of AC. So Q of AC is also matching. Oh, taking a toll of you, isn't it, right? This is the beauty of JEE advanced questions, right? Now let's check the next one. For the delta H of CA is delta U of CA, right? You know, let me write for option D, delta H of CA equal to delta U plus delta of PV, and CA is what? CA is volume is constant, is nothing but isochoric. So how are we going to write this? Delta H of CA is equal to delta U of CA plus V into delta P, right? So you can see here delta P is P1 minus P2. As we all know that pressure is directly proportional to temperature. Since T2 greater than T1, P2 greater than P1, therefore this equation can be written as delta H of CA equal to delta U of CA minus of V1 into P2 minus P1. Am I right? From this you can make out that this value is greater, because we are subtracting some value which is positive from this. That means delta H of CA is less than delta U of CA. Wow. So this is the beauty of this question. So you can see that Q of BC, we have done it already, isn't it? What do you say? Q of BC, where is it? Q of BC is matching with delta H of AC. So in option D, this is matching. But delta H of CA is less than delta H of, this is where it is failing, isn't it? So option D is also incorrect. So A is incorrect. So right answer for this question is option B and option C. This is the beauty of the JEE questions, right? We should bow down to such question, right? But you must solve at the same time. If you respect the fundamentals will respect you and get the right answer at right time. And you can see most of the questions are from second law, clubbed with what you call the equilibrium. So that's why I have fused these two chapters together. I hope you are liking the video, so please press the like button if you are liking the video. Share and subscribe to the YouTube channel. This will give you a free lectures. There's no commercial benefit involved in it. Actually, my intent was to make the videos in Telugu, but you know that the aspirants would be little like, you know, it will scatter throughout the country. So I thought it will be useful for the other state students also to explain the concepts in English. So there are few lectures in English also. So please follow my videos. Suggest to someone who are genuinely interested in chemistry learning. Here there is pure chemistry learning. There is no nuisance. There is no nonsense which will go on. So here we are not making the videos to impress the students. Here we are making the students to influence the students. We want you to influence from the subject or the content that we deliver. Alright, so watch and learn. Then please provide your feedback in the comment section so that we can also make the better videos in the coming time. The only motto to improve the quality of the lecture that I am providing through this tremendous YouTube channel, the fabulous YouTube channel. Now you can see there is a question related to the conversion of the graphite into the diamond, right? Carbon graphite is converting into the carbon diamond. Hope there is a process where we can do that very easily, right? But it is not there. That's the reason why diamond is precious. Under normal condition, you won't get that. You need to apply a huge temperature or drastic conditions so that you can get it. Now we can see the heat of formation or Gibbs free energy of formation of these two is given, and the graphite at temperature, the pressure so pressure is being asked, isn't it? And conversion reduces its volume by 2 into 10 power minus is the only point which I want to tell you, that this is I am not personally convinced with the way this question is asked, because when we apply and solve the question, we will see that these concepts are actually related to the ideal gas, because that the whole set of rules which are framed in the thermodynamics chapter are actually meant for the ideal gas, isn't it? There is no ideal gas, that's why there are rules. But here, while solving these questions, you would be surprised to see that those concepts are also applicable or applied to the solids, liquids, etc. So whenever you write delta G naught equal to minus RT ln K, that actually K is nothing but Kp, not even Kc. Because thermodynamics rules are actually applicable to the ideal gases. But in a general scenario, we have extended them to the non-ideal gases. We have extended them to the solution, making this K as Kc. But this is an extreme case, we have extended that to even solids. So strategically it is correct, but ethically it is not correct, isn't it? Now let's see how to solve this question. Now we can see that the delta G of reaction equal to that delta G of product, that is diamond, minus delta G of reactant. Of course we are talking about the standard values. So first of all I would take that. You can see diamond, because for graphite it is being arbitrarily assumed as 0. So you got the delta G naught of the whole process as 2.9. Isn't it? You got that value? Now what is that you need to do? Isothermally. You can see here throughout the process, the temperature is kept constant. Alright. So delta G values are given and it is said that temperature is kept constant. So which concept you are going to apply here? Just think. You can see that 298 Kelvin is kept constant, isn't it? So which concept you are going to apply? Because another point is also mentioned. You see, isothermally it is converting from the graphite into the diamond, wherein you got the delta G naught value. And where you have to end up is that you have to find the pressure, alright, pressure at which this carbon graphite is in equilibrium with the diamond, right? This whole equation is in equilibrium. which concept you will apply? Think. You know that for all this process, one has to understand that maximum work is nothing but delta G naught. So here whatever value that you have actually calculated, that 2.9 kilojoule per mole, is actually the work done to convert the graphite into the diamond, isn't it? So this is actually the work done. The delta G naught that we have calculated is actually the work done. And you know that Q equal to delta U plus W, you will mention it as Q equal to delta U plus W, isn't it? So we can make out here that the isothermal process, so we take the delta U value as 0, isn't it? For isothermal process we take delta U 0 or not. Therefore the value of Q is turning out to be W. So work done, electrical work, that is 2.9 is equal to, you can see isothermal process, and here the pressure need to be obtained into, it reduces the volume by 2 into 10 to the power minus 6 meter cube. PdV, pressure volume work. Therefore the pressure value is turning out to be 2.9 upon 2 into 10 power minus 6. So this is the value of the pressure that you need to find out during this process. Hope you understood the solution to the question. Of course we have done some vague things, like you have used this first law of thermodynamics, which is actually applicable to the ideal gases, but it's okay if you solve this question by this means, because there is no other way out. It is being mentioned that isothermally, and you have to find out the pressure at which this process is done. So we are assuming that the condition that are imposed through the air on the conversion of the graphite into the diamond equilibrium is actually behaving like an ideal gas, and whatever work that is imposed or done by the air is actually useful in converting this graphite into diamond. It's not that we are just taking this work done as the work done related to this process. It is actually work done by the air, because you are applying that pressure over here. That is the beauty of JEE question. It's not that it is asked actually, we tried to create here some kind of a scene where you thought that it is related to the graphite to the diamond, but actually this is related to the air, which is actually exerting the pressure over there, isn't it? So such a beauty is the JEE questions, right? So here on the whole, or in a nutshell, that this pressure that you are calculating is not related to the pressure at the equilibrium. This is the pressure exerted by the air to achieve this equilibrium. That's why we could apply these thermodynamic rules to the air, assuming that air which is imposing the pressure is actually behaving like an ideal gas. What a beauty, isn't it? I hope you are liking the videos, isn't it? Alright, so I'm signing off. Stay tuned for the next sessions. Alright, that's it for today. What do you say?